Hey, so I wanted to do a quick problem here from my which is bigger quiz. I'll provide a link to this in the description. We have 99 factorial versus 50 to the 99th power. This was a video for Michael Penn I think it was a few months back. And there's a link in the quiz to that video as well. But let's try this. So I thought this was a really interesting problem. I hadn't really thought of it like this, but it's not too hard actually, but it's a good one. So it might be useful. I thought it was useful. I think in the video he did is he wrote it as a fraction. So let's do that. I like that idea. So we can write, the only thing is we're not going to write the whole thing. And then notice, notice in the middle here, we're going to have, and then it's going to go all the way down to 1. So that's 99 factorial. And then 50 to the 99 is going to be, just imagine 99 copies of 50, right? All the way here. I like that because it's kind of like you get like a visual. You can kind of see it. I mean, we can't write the whole thing, but you can kind of see what's happening and get a feel for it. Um, Now let's see. And so you can kind of see like, okay, we're gonna have one value that cancels. Right? That's easy. Then everything here, what we just want to find is it greater than or less than 1, right? If it's greater than 1, that means 99 factorial wins. If it's less than 1, 50 to the 99th wins. We can see that the left part is going to be larger on top, but we can also see that like if we were to divide this into two fractions right here, this side is greater than 1. This side is clearly less than 1. That doesn't really solve anything for us, does it? So the key takeaway is to look at it in terms of pairs. So if we looked at, let's just break out like 99 and 1. So 99 times 1 is going to be 99, but that's going to be less than 50 squared, which is 2,500. So just looking at the first term and the last term, the 50s clearly win. Okay? 2,500 is way larger than 99. Then if we do the second, we'll just compare 98 to 2. 98 times 2 is going to be 196. But every one of these terms compared to a 50 is going to be the same. It's always going to be 50 squared. Okay, so then obviously we keep doing this, but it's going to get a little old here fast. But that is what 391, I believe. But that's clearly less than 2,500. And we're going to keep doing that. These pairs are going to get larger. They're going to get larger and larger. But then, and I forget the name of the inequality. Is it I don't remember which inequality it is, but the the maximum of the maximum of the two terms is going to be in the middle here. The actual maximum would be at 50, but this is going to keep increasing, and then the largest value we're going to get to is 51 times 49. So 51 times 49 is actually, you can look at that as 50 plus 1 times 50 minus 1. A difference is squares. And so that's going to be 24.99. But see, 24.99 is still less than 2,500. So every single term is going to be less than 2,500 matching by pairs. We're actually equal at this one value is equal, but we already crossed that out, so we're not concerned with that. And so at no point does a pair of these terms on top ever equal 2,500. So 25, so the 50 to 99 is going to be it's going to be larger. It's actually going to be much larger, but it's not just, even though it seems close at first, it's like it's every single pair, the 2500 is larger. So it's going to actually be clearly 50 to 99. And that's correct. Wonder. Okay, so I'll leave a link in the description to this quiz. You can try these problems. I have, again, in the help, I have the link to the Michael Penn video this came from. But also, we have a lot of them are exponential, but there's some variety. There's some square roots in there. There's, I think, 26 of these problems in all. So you can give these a shot, and I will leave it there. Thank you.